So that was that. We can talk till the cows come home about performance and low latency. We achieve that in our sleep. But the thing we are proud of, and we already touched upon it in the VI discussion, is if I were to walk into an enterprise customer, that is the priority list that I would give them in order to evaluate a product like this. First of all, it has to be correct. And what we have achieved, although it might not be obvious, is we are doing acceleration. We are actually caching data on behalf of virtual machines in front of a clustered file system, in front of a file system which can modify data from any host in the cluster. And yet we get it right. That is non-trivial. And we are doing it in front or behind all these clustered operations like vMotion, etc. And they don't even know our existence, like I just showed you in the virtual machine configuration. And yet we get it right. We are all compatible with all the solutions that you already can think of. The virtual machine, again, like I said, if you want to take a virtual machine snapshot, well, click the VMware snapshot button. There's no RDMs to worry about or any such thing. There's no guest drivers to worry about. There's no static partitioning of flash. You don't have to figure out how much flash you need to give to a virtual machine because, do you even know? And even if you do today, your workload's going to change with the next Microsoft patch that comes out tomorrow. And so that is the stuff that we take care of. And that is what we are very, very proud of. Not to mention that, it's totally complete. And then there is a lot of thought put into how you would actually deploy it and how you would deploy it at scale. 5 minutes and you're done. And finally, we talk about performance. But when we talk about performance, we point out that it is complete when it comes to performance. This is not a niche solution where you say, well, throw in your read-only workloads. This is a solution for VDI. We say, throw in everything. This is something that you install on an infrastructure level, just like how you install a hypervisor. And then you let the workloads do their thing and let PernixData do its magic. So people ask us about use cases, and when they ask us about that, we ask the question back, is what would you use it for? And in 2 minutes, they have actually talked about every single workload that they run. And that's the right answer, is you think about it as an infrastructure component because it is complete and it's not very disruptive to what you're already doing. But that said, let me show you just some empirical data for kicks. And so, for example, this is a VDI workload, 10 VDI VMs, Windows 7 VMs that boot up and run a file system workload. 80% reads, 80% random. And so, as you can see, the orange curve is a flash throughput. The blue curve is what the application actually sees or what the VM actually sees. And that's obviously an aggregate of all the 10 VMs. And then the purple curve is what the data store is doing. As you can see, as we boot up and this is from a cold cache situation, so PernixData is actually bringing in stuff from the SAN, and you can see the applications are actually hogging the SAN curve because it's mostly, the SAN latency that you see there. The flash throughput is much higher, you can see, than those curves because we are not only servicing the application, but we are also using some bandwidth to warm up our layer. But then as time goes on, the application sees flash latencies and the SAN usage just drops off. We've of course done just a 12-minute test because after that it's just the same old thing that repeats, but you get the point. That's VDI. That's one of the easier workloads. Databases, extremely hard. This is where on a non-PernixData solution, there's not even there's no question of using a database on a read-only solution. This is a write-intensive workload. This is SQL IOSIM running inside Windows 7. There are some very interesting things going on here, so bear with me. But at a very high level, again, the blue curve is what the database sees in terms of latencies. And as you can see, it is flash class, which is close to the orange curve. And in the meanwhile, the database, as it's doing writes, we are destaging it to SAN. The SAN is going all over the place. And sometimes it's just extremely high, by the way. But you can see that the application doesn't see that. Now, there's a reason that I have chosen an extremely, extremely slow SAN for this slide. And the reason is that, with Writeback, the problem is, we are actually buffering data. And then we are obviously constantly writing it out of SAN. And just to maintain fairness between virtual machines, you can't buffer infinitely. And so there is this constant kind of tug of war between the virtual machine writing and trying to fill up our log, and us trying to empty it out in the back to the SAN. And if the SAN is really, really slow, then we are not able to empty it out fast enough. But what I'm showing you here is we are keeping up with what the database requires. And that is a beautiful thing, because even when the SAN is high latency, well, the latency is high, but it can still do batch processing. So that's fine. And that's something that is very, at least, to me, was non-intuitive. Again, I jumped up in my chair when I first saw this curve. And so now, yeah, the latency could be high. We are batch processing. But number one, we are not overwhelming our log space, although it's extremely slow, because we can drive enough throughput. It's just that we can't drive enough latency from the SAN. And that's really the problem. Right? It's the same workload. If you look at the hit rate curve, you can see the most uninteresting curve in the world is it's hogging. The hit rate is hogging almost 100%. The eviction rate is if we were to actually evict the flash device against our will, because there's enough pressure. The eviction rate is almost 0, except for a few blips here and there. So that was all I had in terms of a demo. Now for the technology deep dive, I had the hardest time actually coming up with this section, because, where do I start, right? There is core innovations we've done on flash formats to make flash go as fast as the raw native flash speed, and that is very non-trivial, and I'll tell you why. There is core innovations we've done to actually make sure that when Mr. Marks brings his 16-node cluster to the game, the network latencies and our clustering protocol is not a function of the number of hosts in the cluster. And so it's the same for 16 nodes or 32 or 64 or 2. And you can see it in practice, but I'll talk a little bit about the technology. And so on and so forth. There's obviously hardcore innovation we've done in terms of the actual, taking care of vMersion, doing the whole network remote flash data access. There's the Writeback stuff and taking care of all the failure scenarios that come along with Writeback. What if the host goes down? What if the network goes down? What if the flash device goes down? What if the SAN goes down? Oh, and by the way, I'm digressing, but this is so transparent that you can actually pull out a flash device and the virtual machine keeps running. Try it on a primary storage system. So and so I'm going to be scatterbrained out here. There are multiple topics. I'm just going to keep jumping around, but feel free to ask questions, or if there's a topic that I didn't cover, I'd be happy to answer. The first thing is the on-flash data structures. Now, PernixData has a marked advantage when it comes to doing data structures on flash, and the reason we have that advantage is because we are not a primary storage system. When you are doing a primary storage system, you got to order writes. So for example, a write comes in, you better write enough metadata to make sure, for example, your RAID subsystem is happy. If you're doing snapshots, then you've got to munge around with some copy and write metadata to make sure that the old version is protected. If you're doing replication, well, you got to munge around with that metadata too. So in spite of hiring the best engineers, a primary storage company that tries to leverage flash in its storage system can't go as fast as native flash speeds. That's just a fact. It's not because those guys are morons. It's just because you've got to do all these ordered transactions.
You're not implying they are. You're not implying they are not morons, though, right?
No comments, but that is a big deal. That is a core differentiation as to why we are able to drive those throughputs. 20,000 IOPS on an Intel SSD. that you buy off of Amazon, 40,000 if you use a SATA 3 device. And more importantly, the amount of metadata we munch to service every I/O that is coming into our subsystem is extremely low. This is hard to read, but for example, on the chart on the right, I'm showing a flash device. So there's 3 flash devices, one in each host. It's a 3-node cluster. Each of them is doing around 200 microseconds, 150 microseconds, something like that. Not important. But what I'm showing is the purple curve, which you can hardly see, is the amount of I/Os that the system is doing that is not directly attributable to a virtual machine's data. This is the amount of I/O that FVP is doing on the flash device that is not directly attributable to a virtual machine. The orange curve is the amount of reads that are attributable to virtual machines, and the green curve is the amount of writes coming in from virtual machines that the flash device is servicing, and the blue curve is the overall effect to all these applications combined. As you can see, hardly any traffic, hardly any writes that we impose, and this is very, very special of a system that is an intermediate tier of data as opposed to a primary storage tier. We visited this slide early on. We said you can truly scale out, and you can say you need only that much, but the idea is that come this fall or next summer, you can actually expect this system to keep scaling as opposed to saying, okay, well, now watch. This is a system that you can keep on building out as your demands grow. And it's not always about IOPS. So I'll come to the real thing, which is latency in a second. But before we go to latencies, just a brief note about networking. So the first thing is, like I was saying, this is a system where the clustering protocol is not a function of the number of nodes in the cluster. In fact, the reason we can drive so many IOPS is only if you can make sure that to service every I/O operation through FVP, you're not reaching out to other nodes in the cluster to say, well, I'm the new authoritative owner of this particular block. And that, by the way, is, at least, in my sense, that's rocket science. That's, one of our proud moments, is we are able to do this in spite of working on a clustered file system. So we are able to actually resolve ownership in a large cluster without doing too much network transactions. And that is very unique. That's how we go to true flash throughput. There's no coordinators, like we said also during the videos, there is no single point which actually manages this cluster from a data plane point of view. And so nodes can come and go as they please, and the system keeps running. If you are running in write-through mode, you can have nodes in the cluster which don't even have PernixData installed. And you can actually have VMs that might move to those nodes, and they might come back. And yet PernixData is actually, it figures out that there are writes that the VM did while it was not being managed by PernixData. And so, let me not trust some of the things that I have in my flash on behalf of that VM. So it is that intelligent without running a piece of software on that other host. So it's that beautiful. In Writeback mode, of course, you got to have PernixData on all nodes in your cluster for the obvious reason is if DRS resumes your VM in some other nodes, you want that node to get the freshest copy of the data, and that can't happen.
So other than a
without
performance
FVP.
If a VM is running in Writeback mode, it migrates to a host that doesn't have PernixData.
Mm-hmm.
Is there any issue with that? I mean, I know the performance will suffer potentially.
If a VM that is running in, sorry?
So a VM is sitting on a host that has a flash device and is running in Writeback mode,
Mm-hmm.
and for some reason DRS moves it to a host that doesn't have any PernixData on it.
Yeah, so that's an issue because now the guy won't get the fresh copy of data.
Performance, but it'll still allow the migration, correct?
Oh yeah, absolutely. Well, but we won't allow you to put the the VM in write-back mode in the first place.
Okay.
If we see a cluster that has mixed, some PernixData and
Gotcha.
non-Pernix.
The whole
So-
cluster must be
The whole cluster must be flash equipped
Yeah.
in
In order to use Writeback.
No, only PernixData equipped.
Okay.
You can choose not to have flash, that's fine.
Okay.
How about that?
That's a change.
So it could not have
Last
flash,
time we
but
talked,
still.
Hey, since last time we talked, we've written a lot of code. No, I'm just kidding. But
You're so behind, Howard. Come on.
sorry, I'm sorry I cut you off. Were you
No,
asking?
that works. So it doesn't have to have a flash device specifically, but it does need to be part of the flash cluster of FVP.
It needs to be. It needs to have PernixData installed, right? And it doesn't have to be.
because otherwise it would have to, they'd have to introduce a delay to flush the cache before they let it move.
That plus, you need
So-
to know
If it was,
to actually get stuff from elsewhere,
yeah.
and
if it was-
you need to
If it's in
realize that.
write-through mode, then the data on the backend storage is up to date, and you could theoretically just migrate and get slowed down because you're not caching. But if it's write-back mode, then that workload moves to a server that doesn't have access to the data that's in the cache,
Yeah.
and that would be bad.
I think I'm just running the older code. So I have a 2+1, 2 with flash devices, 1 without.
Oh, okay, yeah. The older code is,
I update my code. Basically it.
you know our address, just send in a check and.
Yeah.
No,
Credit
it's-
card swipe. Make it out to cash, right?
Oh, really? That's funny. I like it.
Make it out to Senator John Thomas, Lagos, Nigeria, area code 419. John's not paying attention.
No, I'm just entering your email
All right, so this question was asked earlier is, if we use the network, then aren't we slowing ourselves down? And so I wanted to give you a perspective of where we see us and our network latencies with respect to everything else that you can potentially use. If you do IOs through PernixData to a local flash device, it's somewhere in the 70 microseconds range. This is a PCI flash device. But we've seen similar stuff with SSDs as well, especially nowadays. If that same I/O has to be done from a remote flash device that is being managed by PernixData, goes somewhere in the 300 to 400 microseconds range. If you deploy an all-flash array with the fastest network possible, you are somewhere in the 800 microseconds range. That is what we've seen, and that's just what it is. It's the bunch of HPA command queues here and there, and this, by the way, is storage systems that are idling. If you put some traffic on it, you're not going to see those numbers. And of course, if you put traffic on us, you're not going to see those numbers too. But the gap, exactly. The best case is this wider gap. So imagine how worse the gap is in the worst case. If you use a traditional SAN system with NVRAM, not these new age SAN systems, latency is similar as long as they are not loaded. Everything's coming from NVRAM. If you use a virtual appliance, you give up hope, obviously. It's around 3200 microseconds.
Abandon all hope he who uses VSA?
Right. Oh, and did I mention that the NetApp that we were running the live demo on was all flash? How about that?
Go dog. Would you like flash on flash?
Yeah, we did flash on flash. Some awesome action there. Here's the networking stuff again. We saw a live vMotion and how it changed the networking stuff. This was an interesting workload that we ran. Again, this is not in the beta, but we tweaked some of our networking algorithms. So we figured, after the network hit rate goes down beyond a certain point, there's no point in consulting the network in the first place. And so what you are seeing here is, a vMotion, and those are the dips actually. And by the way, this kind of exposes problems in multiple places, but at the time of vMotion, the virtual machine literally just stops on the first host and starts on the second one, and you actually see a dip in performance, and it is what it is. But what I want to show you is, for example, if we just focus on that last bit right there, and so what's happening is the virtual machine resumed, we understood that there is some part of this VM that is on some other host. So we established network connectivity to that host. We are pulling in data from that network. As you can see, there is a spike in the flash IOPS, and that's because all that network stuff is again, being used to populate, not only serve the virtual machine, but also to populate flash. And then as time goes on, we see that, well, now the network hit rates are not interesting anymore. So instead of getting one hit in 1,000 or whatever, I'm just making up a number, we figure it's just better to run on local flash. And that's what we are doing towards the end of it. And you can see the network tapers off. It keeps on doing it very consistently in every run. So anyway, again, there are many, many stories I can tell you, but the point is there's some very interesting resource management that we can do. And this is just the beginning of it. There's some fairness that we can do in terms of, that we actually already do in terms of capacity when it comes to multiple VMs using a particular flash device and so on. But these are all very interesting research topics. Like, we can optimize it 1,000 ways to Sunday, but this is just the beginning. And the beginning is pretty good. It is, way off from status quo. When you run PernixData, the SAN becomes healthier because it is serving less load. And so, for example, if we run PernixData versus just running a very, very small workload, literally just one VM running on the SAN and the SAN doing nothing else, we see a 20% decrease in latency compared to running that workload, especially write latency, running that workload directly on the SAN. If we load it up to its regular bounds, a bunch of VMs running from a bunch of hosts, we see a 100% decrease, 135%. And if we are in some crazy scenarios like Bootstorm, way off. It's 660% lower latency from the SAN just because it's serving less data. And this is not rocket science. This is obvious, but since we created FVP, we got this data first, so we are sharing it with the world. The other thing that is not very obvious, but that at least makes me jump with joy, is the actual consequences of Writeback. And so, for example, out here, now for a change, I'm actually showing you vSphere performance graphs. I'm sorry, vCenter, VMware performance graphs. Just to orient you, the orange curve here is writes to the flash device. The green curve is writes to the SAN device. And the purple curve is reads from the SAN device. What we did was we ran a workload, and that, for approximately 10 minutes. And actually, it was really run just for 2 minutes. It was a absolutely write-intensive workload. It was a huge write burst. Workload finishes in 2 minutes. And we ran it again after a little while. But the funny part, the very interesting thing that happens is, bam, and this is a VM in write-back mode. So the interesting thing is Flash absorbs the write spike. So the workload runs at around 13,000 IOPS, and it's happy, it shuts down. And then you see a constant tail of writes going out to the SAN. And that's nowhere close to 13,000 IOPS that the application saw. Now, why this is interesting is this is the new way to design storage infrastructure for VMware, is that, the costs of storage systems go through the roof today because you always design and deploy for the worst case. And that's your worst case. And if I were to change the worst case to a fraction of what you see, then the cost of that storage system ought to be much lower. And even if you ignore the dollar amount.
The worst case is that rate peak runs
forever.
2 IOPS longer than the room in the write cache.
Actually, funny you mentioned that. So we have ways to throttle the virtual machine's input rate so that we don't actually overwhelm our write region, so to speak.
Oh, so as the write region fills, you throttle back?
Yeah, exactly.
Oh, good,
So
because
that you
otherwise the
don't-
cliff is nasty.
Yeah, otherwise it just goes up and goes down, and then then goes up and stalls again and so on. But this is the big impact, is if you actually take performance into this server-side tier, then that's what you design storage systems for.
So on the back end, we've got some iSCSI thing with 472 gig
Possibly,
drives.
yeah,
Yeah,
possibly.
7200 RPM drives.
Right. And like I showed you in the database workload, maybe you don't care about the latency. Of course, you care about the throughput, but maybe you don't care about latency. So in summary, this, again, I guess I'm just repeating myself. I'm getting old, but, we are absolutely 100% software-based solution that virtualizes server flash. And we do it in the most seamless way possible and the most enterprise class way possible. This is absolutely, compatible with, all the hardcore mission critical functions of your IT infrastructure that you rely on. And it is the least amount of work that you will possibly do to solve your biggest problem in the data center today, which is storage. Now, of course, we are asking people to move from status quo, but given that the solution can be deployed in a few minutes, and you can literally see the benefits in a few more minutes, we think that's not a problem. And in the worst case, you remove the virtual machine from the flash cluster. Of course, I dare you to remove that once you get used to that. But this is the new quality of storage that you should expect. This is the new status quo. Now, of course, the old status quo is interesting. It's warm and gives you this warm and fuzzy feeling. You know how to upgrade storage system from one to another or add flash devices to the storage system. But give this a chance, because every now and then, a freight train comes running through your status quo. And PernixData is one such freight train. Actually, I have a picture too. It's a good freight train, though. It wants to take you to a place that you always wanted to be, except you've never gotten to yet. And so, in my humble opinion, jump on it.
Thank you.
Thanks. That's all I had.